This is problem 7.1 that we started in class last week, and this is going to be the completion of it. Actually, we'll work through the whole thing, even though we already did part A. Basically, what's given is a unity feedback system. You can see that here. I don't know if I can get this thing to draw. There we go. So we've got our input, which is R of S. We've got our open loop transfer function, which is G of S. G of S is given as this equation. So we got 450 times S plus 8 times S plus 12 times S plus 15 over S times S plus 38 times S squared plus 2S plus 28. And what we want to do is we want to find the steady state errors for the following test inputs. We've got 25 U of t. That is going to be a step input. And then we've got 37t times U of t. That, since this is a linear function, will be a ramp input. And then finally we have 4t squared times U of t. So that's going to be a parabolic input. Okay, so let's start with part A. We covered this one in class, but if you weren't here, you'll see it now. Okay, so this was a step input, like we wrote above. We need to find R of S. So if you were to look in the Laplace transform tables, you'd find that for a step input, R of S should be 25 over S. Okay, so now what we need to do, since this is a step input, we need to find our error equation that we derived for a step input. So if you look back in your notes, you'll see that the steady state error equation is basically 1 over 1 plus the limit as S goes to 0 of G of S. Now remember, this portion of the equation was just for a unit step. Since we have this 25 here, that is not a unit step. So we need to multiply this whole thing by 25. Alright, so the main portion that we're going to focus on here is this limit. So let's come over here and look at that. So we have the limit as S goes to 0. And then let's write G of S. I won't read that out to you. Okay, so we got that, and then the denominator. Oops, that's an S. Okay, so that'll be S plus 38. And then finally S squared plus 2S plus 28. So we have that. So if we're doing the limit and we're taking S and making it go to 0, then if you notice, the main one that we care about, main term, is this S in the denominator. So if this S goes to 0, that means this whole denominator is 0, which is going to mean that the limit goes to infinity. So then if we take that, plug it back up into this equation here, we get 1 over 1 plus infinity times 25. And obviously 1 over infinity is going to be 0. So our steady state error using a step input is equal to 0 for this system. Okay. Now I'll do the same thing for the ramp input. So we have 37 times t times U of t. We need to get R of S. So again, you would look up in your Laplace transform tables, and we would see that that's 37 over S squared. Okay, so now we've got that. Now we want to use our error equation that we derived for a ramp input. So that equation is going to be 1 over the limit as S goes to 0 of S times G of S. And remember, this equation was if we had a unit ramp input. Now I've got this 37 here, so let's multiply by 37. Okay. So looking at that, if we focus on this denominator again, what we're going to end up with, we have S times G of S, so let's write that out. So now I've got S times the 450 times the S plus 8 times the S plus 12 times S plus 15, and we're going to put that over the denominator. So S times S plus 38 times s squared plus 2s plus 28. So now we have that. Now we're going to take the limit as s goes to 0. So if we do that, if you notice first, these s terms are going to cancel. And then basically what we're left with are a bunch of numbers that need to be multiplied together. Because this s goes to 0, this goes to 0, this goes to 0. And all of these go to 0. Okay? So what we're left with then, we've got this 37. Let's put that there. And then the denominator is going to be 450 times 8 times 12 times 15. And then that's going to be over 38 times 28. So let's make this bigger. Okay? So now we've got a bunch of numbers. Do the math. And you get 0.06075. Okay? So that's your steady state error using that ramp input. Okay? So this one basically would have a constant error as time is increasing. With the step input you would have 0 error. Now let's see what happens with the parabolic input. So for this one we have 4t squared times u of t, find r of s, and that's going to be 4 times 2 factorial over s cubed, so that gives us 8 over s cubed. Now we get your equation for a parabolic input. We're going to have 1 over the limit, as s goes to 0, of s squared times g of s. I'm going to multiply that by 8 again, okay, because remember now we have this 4 term here, which leads to this 8, so that 8 needs to come down here. So let's focus on the denominator, because that pretty much determines what we're going to end up with. So now we're going to have s squared times g of s. So we'll have s squared times the 450 times s plus 8 times s plus 12 times s plus 15, and then we put that over s times s plus 38 times s squared plus 2s plus 28. Okay. Now let's cancel the terms that we can cancel. So this cancels with this. So that means we've got this s on the numerator. Okay, remember we're taking the limit as s goes to 0. So that means this s is going to go to 0. So the numerator is 0. So that means this whole thing is 0. And then if we plug it back into this error equation, we basically end up with 8 over 0. And anything over 0 is going to be infinity. Okay? So that is your steady state error for parabolic input. So basically we have infinite error. So the error is just going to keep growing as time increases.